So first, let us see what sliding window property is. So sliding window is a technique that is used to uh, solve the basic patterns in arrays and also strings. So we can come to a conclusion that it reduces the complexity from being O of n square to O of n. That means without using a sliding window pattern, we'll be having the complexity of O of n square. But if we maintain a window which is sliding from left to right or from right to left, and we move smartly according to the conditions, the complexity becomes O of n. Easy, right? So let us see how it actually looks. So let us say that this is an array. So let's have L and R as the extremist elements. So L is at left and R is at right. So we expand the window by incrementing R because the window gets bigger by incrementing R. We go to the right side so that we expand the window. But if we want to shrink the window, if we want to change the size of the window to a smaller portion, that means we are shrinking it, we need to move left to the, L to the right. Right, that means not actually moving, but you're incrementing L. So we are shrinking basically based on the conditions. So when we are using this pattern, so we use this patterns whenever this comes, like subarray, substrings, and we find keywords like continuous and sub, right? And we can also use this when we need to find maximum and minimum or a count of valid subarrays. We need to count how many subarrays are there and they are all valid, and we need to find longest or shortest window possible in the given array. So as I told earlier, these are the keywords. So let's move on to the types. So we have fixed window size as our first type. So the window size need not be variable, but it is fixed, it is a constant one. So for example, we need to find the maximum subarray of size k. That means we have a fixed window size of k, the value k, there is some value, integral value k. So we only need to maintain the size of this window in the value of k. So if we solve this problem using brute force, we will be having the complexity of O of n times k. That means O of n into k, which is bigger, right? Which is very complex. But using this optimal sliding window pattern, we reduce this complexity to O of n. So let's see an example. So this is a very easy example to understand. So we have an array 2, 1, 5, 1, 3, 2. So we have basically 6 elements over here. So we need to maintain the window size as 3. So first, if you don't understand what a window is, what a sliding window is, basically we here we have the size 3. So in this array we initialize the first window with the first 3 elements. So eventually we will increment we will be sliding this window across this array in a direction, right? So we start from left, then we will moving on to the right. So let's see the first step. So we have our sliding window at the position, array position 0, 1, 2, right? So here we have this index values. Okay, so we will be having index values like 0, 1, 2, 3, 4 and 5, right? So we'll be initially starting with 0, 1, 2. So we'll calculate the sum of this subarray, okay, which is nothing but 2 plus 1 plus 5 for this window, which sums up to 8. Now let us substitute, let us take the maximum sum to be 8 for now. Then we will calculate, we will compare which value is greater to compute this maximum sum, right? First of all, our objective is to find which window gives the maximum sum. Okay, so we need to find that window and also the maximum sum. So we have computed up to this, until this, right? So next we need to expand the window, but here we see this is a fixed window size. So if we increment the window to include this one also, then it becomes 2, 1, 5 and 1 again. So the size becomes 4 and not 3. So the condition is 3. So if we want to slide the window, we need to add one element, and also along with that we need to delete one element, right? So in order to do this, we move on to the second procedure here. Let's say we need to add, let me put the index number 0, 1, 2, 3, 4 and 5, right? So we need to move from 0, 1, 2 to 1, 2 and 3. So we need to delete the 0, right? And we need to add this element at 3, index 3, right? This is what we have done here. So we now have the elements 1, 5 and 1. So what we do here is, again we are going to compute the sum, right? So we compute the sum where we use the previous value. We need to find the sum again, like 1 plus 5 plus 1. No, we need not do that. Instead, what we are going to do is that we'll be using the previous sum. So 2, 1, 5, right? So we already have 1 and 5 over here. So we just need to remove this 2 and add this 1 from the overall value, right? You understand? So we'll be having this 8 plus 1. We are adding this 1 to the 8 and we'll be removing this 2 from the 8, right? Finally we'll be getting the sum. 1 plus 5 plus 1 is equal to 7, and that is what exactly we get here. And we can compute maximum sum from the maximum of the previous value 8 and from this new sum value 7. So out of these two, 8 is greater. So we are doing this continuously until the end is reached, right? So now we need to slide again. So we have 5, 1 and 3, right? Again the size is 3. So we use sum. So the previous sum 7, and then we add 3 and then we delete this one. Add array of 4 and then remove array of 1. That means array of 4 is nothing but we have 0, 1, 2, 3, 4, 5. So we need to add the element array of 4 in the index 4, and then we need to remove the element at array of 1, right? That is what we did here exactly. So we have the previous sum to be 7 plus 3 and minus 1, and we have here 9. So we need to compute the maximum sum. We are comparing the already we have the maximum sum to be 8 over here. It has not changed here because the maximum out of these two is again 8. So we are comparing it here again with this new sum and the old sum. So 8 and 9, out of these two, 9 is only bigger. So we update the value of the maximum sum. So it becomes 9. Now we need to slide the window again. So here we are going to add the last array element. Array at the index of 5, and we are removing the index 2 element 5 again, right? So here we have 1, 3, 2. So the previous sum value is 9. So 9 plus 2 minus 5, which equals to 6, and we are checking this again, and out of these two obviously 9 is greater. So the maximum sum is going to be 9. Out of all the answers, 9 is the maximum sum, and the window which gives this sum 9 is exactly this 5, 1 and 3, and this is what is our answer. I hope you understood.